Aloha and welcome. In this video, we're going to be talking about the queue interface. So let's go ahead and dive into the book here. So a queue is essentially a line. The thing to remember about a line is that you remove from the head and you enter from the back. So when you line up, it's the person in the front that's seen first, so they're the first removed from it, and then people that come in afterwards, they are added to the back. So that's why you need to think about these. So Q, of course, comes from the British idea of a line. It's just one of those neat little differences between the English language between America and Britain. But anyway, so the Q interface, it's defined in the Java collections framework as a collection of ordered elements. And again, it supports element insertion at the tail and element retrieval from the head. So the way you're going to go ahead and define that in code is you're going to go ahead and use this right here. And you notice that here we're saying Q, the type Q, and then T is the type for that. We can have strings, integers, doubles, whatever you want there. And then we're implementing it as a new linked list, and then we use the type again here. So pardon me, Java supports the automatic conversion of an object, for example, linked list to a reference variable of an interface type. So in order to get access to this, we're going to need to import two different things here. At the top of our code, we're going to need to throw in these two statements. We're going to need import Java util linked list and import Java util queue. And that will enable the use of both linked list and the queue. So a queue's add method adds an element to the back, to the tail of the queue, and increases the queue size by 1. Then when you go to remove it, you're actually going to remove the one from the front, and that element will be returned as the result of that method call. And if the queue is empty, you're going to throw an exception. In other words, if you try to do a remove to get one out of it and there's nothing in there, you're going to get an exception. Not a blank or a null or anything like that. You're going to get a full-on exception. So you'll need to be careful there. So we're going to go ahead and look at the participation activity here. It says queue add method adds an element to the tail of the queue, and remove method returns and removes the element at the head of the queue. So we hit start here, and it goes in and declares it. We're using string, and we're doing a linked list of string. So we add Newman party of 1, Amdahl party of 2. Then we're adding the Flynn party of 3. But you'll see we've got the head up here, and we've got the middle, and now the tail. So the next step is we're going to remove the first one. So that removes the first one that we entered, then the next one that we entered, and then the last. So this is essentially first in, first out, last in, last out. So now we go down to the next participation activity. This will probably quiz us on, how to actually go about doing what we just did. So Q integer of orders Q equals new linked list of integers. So we're dealing with integers here. We're adding 351, 352, 353. Now complete the statement to add the value 354 to the tail of the queue. So how do we do that? Well, we know that adding simply puts that to the back of the queue. So we can go ahead and put that in there and check. And of course, that's what it is. Then you're going to have to go in here and look at how to get print the element from the head of the queue and continue, just testing your knowledge of what you just learned above. Common queue methods, and this is where it gets a little bit tricky. So add, so when we add a new element, we're going to be adding it to the tail. So when we do that, the queue increases its size by 1. When we do a remove, it's going to remove the actual element and return it as the result of that of the remove command. So when you do a remove, it's going to return that value to you. So the value in the head position. So then there's something called poll. Now poll is going to remove and return the element at the head of the queue if the queue is not empty. Otherwise, it's going to return a null. So this is kind of like a safe alternative to the remove. So if you want to not have to worry about it throwing an exception if it's empty, then you can use poll versus remove. Then we have element. An element is going to return, it's going to return but not remove the element at the head of the queue. And this also will throw an exception if the queue is empty. And then we have peek, and just like poll, peek is going to return but not remove the element at the head of the queue if the queue is not empty. Otherwise, it's going to return a null. So that is a little bit different from what we've been doing before. We're throwing exceptions here, and we do have alternative methods to call that will return a null instead. So the programmer should select the queue implementation that is appropriate for the intended task. This material will use the LinkedList class, but examples can be modified to use other queue implementations such as the priority queue, the link blocking queue, and the array blocking queue, among others. That's a little bit beyond the scope of what we're going to be doing here. So let's just continue with the LinkedList version. So anyhow, here we're going to go and look at the output of the queue. So go ahead and start. And when we look at we've got to supply the output. So we're looking at what goes in. I'll do one, you do the other. So when we look here, we've got a string of colors. We're blue, yellow, and brown. So we've got a blue, yellow, brown. We do remove. That's going to return the word blue. So yeah, so once we've removed blue, then we're going over here and we're doing a print line of colors removed. So we've got yellow now at the top. So this should be yellow with an enter after it. And that is correct. So I did this one, you do the next one. Then the queue interface. The queue interface here, declare variable weights queue as a queue of type double. Assign weights queue with a linked list of type double. Read 3 floating point values from input and add each number into weights queue. So example, if the input is 42.0, 32.0, 44.0, then the output is going to be 42.0, 32.0, and 44.0. So the first thing to do, and I'll go ahead and start this. I will let you finish it, but we're going to put in our declaration first. So if we want to be efficient, we can grab the first line there, put that in here, and we've got, we'll have to modify this, of course. So weights queue, we'll call this weights queue, and it's going to be double. And over here, we've got double. So that's going to give us the definition right there. So declare variable weights queue as a queue of type double, as we did. Assign weights queue with a linked list of type double. Okay, read 3 floating point values from input and add each number. Okay, so we're going to need to, all right, we've got our scanner set up over here. So our code is going to go here. So it's asking us to read in 3 values. So we'll go ahead and do that. So let's say for integer I equals 0, I is less than 3 because we're starting at 0 and going to 2, so that's 3 values. Then I plus plus, then we open and we'll close this as well. So so it wants us to assign weight queues with okay. So we will go ahead and say weight queues dot add, and we're going to be giving it the results of that. So say scanner dot next double, I believe that would be next double. So we add it like that. Don't forget our semicolon at the end because it's no fun without a semicolon. So we add those in there. So we read the 3 and then from input and add each number into the weights queue. So that looks like it's correct. So we go over here and check it, and now it blows up in our face. Oh, no, it didn't. It worked. Okay, great. So go ahead and work on the next parts. So you'll see you'll have to fill in the code for what they're asking in different places. So now they're going to have you work on the while. And I think they already have the definition for it. Yeah. So go ahead and finish the other 2 parts of this challenge. I think that's all for this section. So if you have any questions with the queue, the main thing, just remember queue, you serve from the front, just like, when you form a line, the people in the front get service. They're the ones that are returned when you're removed, and people that come after go into the back of the line, so they come in at the tail end. So keep that in mind. Go over your methods and the differences between them. Know which ones are safe that won't throw exceptions, and think of different ways to use those. So anyway, if you have any questions, feel free to reach out, send me an email. I'd be happy to answer. Have yourself a great day, and I'll see you in the next lesson. Aloha.